Hi all. Today we'll be discussing the LeetCode problem of the day, minimum penalty for a shop. So here you're given a customer visit log represented as a string, which contains the characters only n and y. So if the ith character is y, it denotes that a customer visits at the ith hour. And if the ith character is n, that indicates that no customer visits at the ith hour. So here you can close the shop at any hour, and the penalty is calculated as follows. So suppose you choose to close the shop at uh, hour 4. So that means before this, the shop is open. So this is the open part. And after this hour, the shop is closed. So when the shop is open and the shop is closed, you have the penalty as follows. So when the shop is open, which is this part, and no customer visits, then you will have one penalty. And if the shop is closed and you have a customer, then also you have one penalty. You have to return the earliest hour at which the shop must be closed to incur a minimum penalty. Also note that if a shop closes at jth hour, it means the shop is closed from jth hour till the end of the customer log. So for example, in this case only, if we choose to close the shop at hour 4, then let's see what the penalty is. So at the starting R0 to R3, the shop is open, and here the shop is closed. So the first at R0, a customer visits and the shop is open, so no penalty. At R1, you see that there are no customers, but your shop was open. So you will go to the first case and it will cause one penalty. So let me just write it below this. So here you'll have 0 penalty. Here you will have 1 penalty. Here again, shop is open and you have a customer, so 0 penalty. Here you have 1 penalty. After this, the shop is closed. So when the shop is closed and no customer visits, you don't have any penalty. And here the shop is closed, but you have a customer, so you have 1 penalty. Here again, same 1, 0 and 1. So when you, if you decide to close the shop at R4, then your total penalty comes to be 1, 2, 3, 4, 5. So you just have to minimize this penalty by choosing a earliest time which you want to close the shop. Now let's look at the examples. So in the first example, you have the string as y, y, and y. So here, like he explained the question, if you close the shop at R0, then your total penalty will be 1 plus 1 plus 0 plus 1. So when the shop is closed, the customer visits, so 1 penalty, and the shop is closed, so 1 penalty, here 0, here 1. So in this case, the total penalty is 3. Now suppose you want to close the shop at R1. So when you do this, at R0, since the shop was open, you have 0 penalty. And here the shop is closed, so 1, 0 and 1. So in this case, your penalty is 2. Now if you choose to close the shop at R2, then here, since the shop is open in R0 and R1 and the customers are visiting, no penalty here. And here the shop is closed and no customer visits, so again no penalty. And here shop is closed and but a customer visits, so 1 penalty. So this will give you a total penalty of 1. And if you choose to close the shop at this point, then your penalty will be 0, 0. Here you will have penalty 1 because at this point shop was open but no customer visits. And here the shop is closed and you have a visitor, so again 1 penalty here. So the total penalty is 2. Also, you can choose to close the shop at the end of all the customers. So you can choose to close the shop at this point also. So when you do this, that means in all the days the shop is open. So when the shop is open, here no penalty, no penalty. Here you have a penalty because customer is not visiting and the shop was open. And here also no penalty. So in this case also you have the penalty as 1. So here you can see the minimum penalty, you have 2 occurrences. So this indicates you close the shop at R number 2, which is at here. And this indicates you close the shop at R number 4, which is here. So out of this, he asks you to return the earliest hour at which shop must be closed to incur the minimum penalty. So out of these two minimum, you have to return the earliest one, which is the hour number 2. And that is your output. Now let's look at the second example. So you have all ends. So no customer visits. So the optimal way is to close the shop at R0 itself. So when you close the shop at R0, you will have all 0 penalties. So output will be 0. In the output, we are returning the R at which we are closing and not the minimum penalty. And finally, in the last example, you have all Ys. So here as well, it is best to close the shop at R number 4. Because when you do that, since that will mean shop is open in all these hours, so you'll have 0 penalty. And the answer is 4 because you choose to close the shop at R number 4. Now coming to the constraints, the customer's length can be up to 10 power 5 and the customer character contains only Y and N. While editing the video, I realized that most of the time instead of R, I'm telling it as a day. So kindly consider this as R whenever I say it as a day. Now let's go the approach. So we'll just iterate on all possible days and we'll see on which day we close the shop and we'll incur a minimum penalty. Suppose if we want to check if we close at day 4, R4, what is the penalty? So for that, when you close at R4, the string will be split into 2 parts. The left part denotes the shop is open in all these hours, and the right part denotes the shop is closed. So in the left part, if you want the penalty, you just want to count all the occurrences of n, because the left part is open and you will get a penalty only when no customers visit when your shop was open. So in the left part, you have 2 n's. So penalty here is 2. And in the right part, the shop was closed. So when the shop is closed, you want to count how many y's are present and that will be a penalty. So in the right part, you have 3 y's. So a total penalty, if you close at R4, will be 5. So now suppose you want to find your answer for, suppose you want to close your shop at 5. So for this, what you need to do is, again, this will be your split. So you close your shop at R5, you have to iterate from index 0 to index 4 and count how many n's are present, which is 2 here. And from 5 to 8, you have to iterate and count how many y's are present, which is 2 in this case. So the penalty is 4. So one thing we can notice, we are doing repetitive computations, because when you computed for this 4, you already got to know how many n's are present from index 0 to index 3. Now when you want to compute for index 5, you want to know how many n's are present from index 0 to index 4. So again, instead of iterating from index 0 to index 4, if you already know what the answer is for index 0 to index 3, you just need to count this character, and that will give you your new answer. So this concept is looking similar to a prefix sum. So we can use the previous sums to get the sum of the current value. And similarly, for the right part, you can use a suffix sum. So let's see how we can use prefix and suffix for this one. So let me denote two arrays. One is prefix open of I. So this will denote count of uh, ends from index 0 to index I. And we'll have another array which is suffix closed of I. So suffix closed of I will denote count of y's from index I to the end of the array, which is n-1. So for this array, let's quickly build these two arrays, these two prefix and suffix arrays. So first, the prefix open. So according to the definition, prefix open of 0 will denote count of ends from index 0 to index 0. So in index 0, we see that we don't have any n, so this value will be 0. And next, in index 1, according to the definition, you will have count as 1, because in this part, there are 1 occurrences of n. And at index 2, again, you'll have 1. At index 3, you will have 2. 2 because in this range, from index 0 to index I, you have 2 n's. And here you have 2, and here again 3, and so on. So the way you fill this prefix array is prefix of I equal to prefix of I minus 1, which is the previous value, plus 1, only if the current value is n. That means you will only increase the prefix value if you see an n. So here we can see that you have a 2. The next value is also the same as the previous value, and it is not incrementing because the current value is y. But here if you see, this value is same as the previous value, but because the current value is n, you will add a plus 1. So that's how you build a prefix array. So let me just fill it now. So here you have 3, then 4, and 4. Now similarly, let's build suffix array, but this will be from the end. So according to the definition, suffix closed of n-1 will be count of y's from index I to index n-1. So at this point, you have 1 y, so the value will be 1. Next, here you have again 1 y, so value is 1. Next, here you will have 2 y's. You have 2 y's in this range from I to n-1, so you'll have 2. And the same thing follows. So 2, then 3 because you found a y, then 3, again you found a y, so again plus 1, and 4, and then you have y, so it's 5. So once you have built the prefix array and the suffix array, now if you want to know, if you want to close the shop at 4, your answer will be simply prefix open of I minus 1 plus suffix closed of I. So here I is 4. So let me just write it here. Prefix open of 3 plus suffix closed of 4. So prefix open of 3. Okay, so if we close our shop at 4, that means from index 0 to index 3, our shop is open. And from index 4 to index 8, our shop is closed. So prefix open of 3, this prefix value, according to our definition, will count how many n's are present from index 0 to index I. And that's exactly we want here. How many n's are present from index 0 to index 3, which is, you can get it from this value, 2. And similarly, suffix closed of 4, according to the definition, will give you count of y's from index 4 till the last. So here also, you just want to count how many y's are present from index 4 to index 8. And that value you can get it from this suffix of 4. You can see there are 3 y's here, so you have 3. And here you have 2 n's, so the prefix value is 2. So when you add both of them, you'll get the penalty as 5. So when you close the shop at 4, your penalty is 5. So the same formula you will repeat for all the days, and whichever is the minimum day, that value will return it. Now let's quickly code the approach. So let me take 2 arrays. First will be prefix open and next we'll have suffix closed. Also we need to take the n, which is the size of the customer string, equal to dot length. So now first let's fill the prefix open. So prefix open of 0 will be 1 only if in the string the 0th value will be n. So if customers dot at 0 equal to n, then prefix open of 0 will be 1. And after that, for I equal to 1 till the end, we'll just run a loop to fill the values. So int equal to 1 less than n. So we have prefix open of I equal to same as prefix open of I minus 1. Now the only change, you'll only have an increment if the current character is an n. So you can just add this again here. So if the current character is equal to n, then prefix of I will be incremented by 1. So this formula essentially means is if the current character is n, then prefix open of I equal to prefix of open of I minus 1 plus 1. And if the current character is equal to y, then you will not add the 1. It will just be the previous value. So the same thing we can apply to build our suffix array as well. So for the suffix array, first we check the last character. If it's equal to y, then we'll have suffix closed of n minus 1 will be equal to 1. Next, you'll start iterating from n minus 2 from reverse order. I minus minus. So suffix closed of I will be equal to suffix closed of I plus 1. And now you will check if the current character is equal to y, then your suffix closed of I will be increased by 1. So by now you have computed your prefix array and suffix array. So now you just want to calculate the penalty for each day. Now suppose, let me quickly take an example. Y n 0, 1, 2, 3. So the earliest you can close is at R0. So when you close at R0, that means the shop was never open, and from index 0 to index 3, the shop is strictly closed. And you can get the penalty from suffix closed of 0. Because by definition of suffix, it indicates the count of y from index 0 until the index n minus 1. So if you close at day 0 equal 0, and your penalty will be suffix close of 0. So day 0 is done. Now let's iterate from day 1. I equal to 1, I less than n plus plus. So at any day, if you want to find the penalty, you will have the value as prefix open of I minus 1 plus suffix closed of I. So this is your penalty if you choose to close at I equal to 1. So now you will check if this quantity is less than your previous penalty. That means you have found a better answer. So you'll update your penalty to be the current new value, and then your answer will be this I, because at day ith r you found a penalty which is smaller than the previous penalty. Okay, so closing the shop at j equal to 0 is checked here, and in this loop you are checking from 1 until n minus 1. But you can see that you can also close a shop at n. That means you can close the shop at this hour also. So this indicates the shop is open on all the days. And to get the penalty for that, you can use the prefix one. So the penalty will be prefix open of n minus 1. So by definition, prefix open of n minus 1 will denote the count of n's from index 0 to index n minus 1. So this is your penalty. So again, you'll check if this penalty is less than my previous penalty. If it's less, then you'll update your penalty, and then you'll update your answer to be n. That means you're closing at the nth hour. Finally, at the end, you will just return your answer. Okay, let me submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. So before that, let me just add a comment on this. So this indicates shop closes at R0. And in this for loop, this indicates the shop is closing at Ri. And this final check indicates the shop is closing at Rn. So out of all these R's, we'll check which R is giving you the minimum penalty, and you'll return that R as your answer. So first, you're creating the prefix array and suffix array, and you're running a loop to fill the prefix array. So this is order of n. And similarly, a loop for the suffix array. So this also order of n. And finally, you're iterating on the days from 1 to n minus 1 to compute the penalty. So this is also order of n. So the total time complexity will be order of n. Now coming to the space complexity, you have declared two arrays, prefix open and suffix closed, both of size n. So space complexity will also be order of n. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.